Let's get together and build a Spring microservice. In fact, let's build an entire application that makes use of multiple microservices, putting it all together in this sweet little front end. Welcome back to Do Some Dev. My name is Gene. There's a big chance you got to this video after having watched my video on the power of Spring Microservices. It aims at providing you with a good overview over Spring Microservices, but without the technical coding part. And that coding part is what this video is all about. For a better understanding, we will build a project in which we create a set of 5 microservices, consisting of a product catalog service, an order processing service, a payment processing service, a shipping service, and another one for the user view. To run all of them, we will put them in one Docker container each and only expose port 8080 of the user view. As a result, we will have a set of 5 Docker containers. To enable communication between them, we will make use of Docker's virtual network technology. We will build all the backend microservices in Java using Spring Boot. And for the user view, we will build a simple GUI using the React framework. The example we built in this video can be found on GitHub. So if you feel like taking a look at the code, you can find the link to the repository in the description of this video. Okay, let's start with a mini Spring Boot project. To kickstart such a project, we head over to the Spring initializer at start.spring.io. Here we can set up our project according to our wishes. Let's use Maven as our build automation tool of choice. If you prefer Gradle though, be my guest. It offers comparable functionality. Regarding the language, let's choose Java, but obviously you could just as well choose Kotlin or Groovy. The Spring Boot version can also be chosen. We see that we can choose between snapshot versions, an M3 version, and just versions without appendage. I want to focus on stability rather than the latest functionality, which still might contain bugs. Therefore, I will avoid using snapshot versions. Regarding M3, we speak of milestone versions. These are pre-released versions that indicates a significant milestone in the development process. They tend to be more stable than snapshot versions, but may still contain bugs. That leaves us with the general availability versions, which are currently 3.3.4 and 3.2.10. And because 3.3.4 is the newer one, I will choose this one. As the artifact, I will provide catalog, which will automatically update the name field, as well as the package name field. To describe the project, let's input demo catalog microservice. Regarding the packaging, which means the resulting application format we get after building the application, we have the choice between a jar and a more traditional WAR file. Let's choose jar. Regarding the Java version, it depends what version you have installed on your system. The version I have installed on my system is the OpenJDK 23, and I can think of no reason why I would choose to build upon an older version. Therefore, I select 23. What we need for our project is a dependency called Spring Web. This enables us to build a RESTful web service while making use of the Spring MVC. Adding this dependency can be done by clicking on the Add Dependencies button and then typing web. This narrows down the possible dependencies we can add to our project. At the top we should see Spring Web. Clicking on that will add this dependency to our project. Now we are ready to click on Generate, which will bring us to download a zip containing the Spring project with all our settings. Obviously, we need to do this exact same setup as well for the other services: catalog, order, and payment. Okay, let's use Visual Studio Code, which is my IDE of choice, to take a look at the contents of the zip we just downloaded. So let's unzip the zip. What we can see here is the complete Spring Boot project that we just defined and generated on the Spring Initializer website. From here we have all the tools we need to create our first little Spring microservice. What I like to do is create build scripts for building the application. They do none other than call the nvnw file to instruct it to build the application. I find remembering these nvnw commands always a bit difficult, while remembering that there is a script called build is much easier. So here we have one of the build scripts for Mac and Linux and another build.cmd script for Windows. The same applies to running the application. Here I always create one run script for Mac and Linux and one run.cmd script for Windows. Okay, we are ready to run our Spring Boot application by making use of the run script. Opening the browser to localhost :8080 will result in this white label error page. It looks like an error, but it actually is a good thing. It means that our application is running. It cannot show anything more than this because we haven't yet implemented anything. Let's change that. Let's create a class product controller and annotate it with @REST-controller. What this does is indicating that this class handles HTTP requests and returns RESTful responses. We will also want @request mapping, which we point to /API/product. This tells Spring to send calls to this URL to exactly this class. We will also add @cross-origin to enable CORS, which is cross-origin resource sharing. This will ease up life a little during development. We can comment this later if we want. Now let's create a new public method getGreeting, which returns a response entity object, which represents the HTTP response with a generic type set to string, indicating that the response body will be a string. To react to simple HTTP GET calls, the method also needs to be annotated with @getMapping and be provided with /greeting. Now all the GET calls to /API/product/greeting will be sent to this exact method. The return value consists of response entity's OK method, defining the HTTP response status code 200 OK. This is followed by the body method containing the string welcome to the catalog microservice. That's it. Let's run the application again and head over to localhost /8080/API/product/greeting. Now we see the welcome message that we just defined. Now let's make sure our catalog service returns us a list of products. For that, we define ourselves a new product class with an ID, a product name, a quantity, and a price. And for all these private variables, we also define the appropriate getters, setters, and constructors. Now we go back to the product controller and add another method getAllProducts, returning a response entity of a list of products. We just simply want to access this method using the request method get @/all. What we do now is define ourselves a set of 3 mock products that we add to a list, which we then return with response entity using an OK and placing the list of products into the body method. That's it. Let's rerun the application and head over to localhost :8080/API/product/all with the browser. Now we see the list of products we just defined in a JSON format. That should be enough of a demonstration of the product microservice. Now let's take a look at our next one, the order microservice. With this name, its purpose should be quite clear. We want to build a microservice that handles the order process for us. Within this Spring Boot template, we also start by creating a new controller, which is the order controller. We will annotate it with @REST-controller and @request mapping, pointing to /API/order. And we will also annotate it with @cross-origin. Just like before, we will create a new method getGreeting and annotate it with @getMapping, pointing to /greeting and responding with the message welcome to the order microservice. Now we also need a possibility to place our orders. For that, we create a new method orderProducts, which takes a list of products and creates a response that will be returned as a string. The structure of the products is the same as in the product microservice. We will not reinvent the wheel and therefore just copy the product class into the order microservice. Okay, let's get back to the order products method. The response we create is just a comma-separated list of product names and quantities. Until to this point, this method is not connected to any URL because of the increased complexity of our parameters. We will annotate this method with @postmapping, meaning that we will need to access this method using the request method post. Because we did not provide any URL, the method will react on the @request-mapping URL we set to the class, which is /API/order. Just like in the Spring Boot project of the product microservice, we need the build and run scripts. They are identical and can just be copied. Okay, let's run the application and head over to localhost :8080/API/order/greeting for the greeting message. Here we are greeted with a warm and friendly welcome to the order microservice. For testing the order processing, we need to send a post request. A good tool to do that is the application Postman. Here we first define the URL we want to send the post request to, which is localhost :8080/API/order. Then we set the header content type to application JSON, telling the API we connect to that this is the format that we send our request in. We also need to send a body. That's the information our order product method gets as a parameter, which is a list of products we send in the JSON format. That's it. We can now send the post request. So let's do that. And here is the body of the response, providing a string of the product names and the quantities. That's all for the order microservice. Now let's tackle the payment microservice. Let's start by creating a payment controller and annotate the class add_REST_controller, as well as add request mapping pointed to /API/payment. We also annotate with add cross-origin. Like in the other services, we create a getGreeting method and point it to /greeting. We will need the product class, which is the same as we have already used in the other services, and can therefore be copied. Let's get back to the payment controller and implement the method payProducts, which takes a list of products as a parameter and returns a string. Here we can place the products we wish to pay, and as a response we get a string message from the system. We annotate this method with add_POST_mapping, without URL parameter. Last but not least, we create the build and run scripts, just like in the other two projects. Alright, let's run the application and head over to localhost:8080/API/payment/greeting with our browser and enjoy our payment microservice greeting message. To test the payment processing, we use Postman to send a post request to the URL localhost:8080/API/payment. For that, we also need to set the content type to application/JSON in the headers section, as well as provide a list of products we want to pay to the body section. Now let's set up our fourth and last microservice for shipping matters. We need this one to delegate the responsibility of shipping the products that we ordered. The first thing we do is create a new class shipping controller. We annotate it with add_REST_controller, add_REST_mapping, and point it to /API/shipping, and add cross-origin. We also implement a greeting method. Because we again will need the product class, we will copy it from the other projects. It's identical. For the shipping process of our application, we create a method called shipProducts that takes a list of products to be shipped and returns a string message for the status. The build and run scripts are the same as in the other projects and can be copied. Let's run the application and head over to localhost:8080/API/shipping/greeting with our browser. Here we get our excellent greeting message. Now let's place some products we want to ship. For that, we return to Postman and create a post request to localhost:8080/API/shipping, which needs the content type set to application.json and which also needs the list of products to ship. Okay, ready to go and trigger this request. As expected, we get the response message listing the product names including their quantities. Okay, at this point we are fully done with our microservices. We have two steps left. The first one is that we still need a front end so that users can easily make use of the microservices. The second one is that in order to test and properly develop all that, we need to bring all the microservices together to appear as a single API. One way to do that is to make use of the web server Nginx. Let's start with the second one first. We create ourselves a run script. Well, a bash script for Mac and Linux and a batch script for Windows. What it does is first copy all the microservices into a temporary folder named TMP. One by one it will build all the microservices. Then it will define a set of variables that correspond to the Docker image name and version that we will create. After that it builds 5 Docker images, providing the according variables and also the according Docker file. After having done that, the TMP folder is removed. Lastly, the command docker compose upd command starts all the containers according to a file named docker compose YML. Before diving into that, let's create a Docker file named dockerfile-catalog. This file is used by Docker to create a Docker image, which will later be used to create a Docker container. First we have the from command. We pull an image named Amazon Corredo in a version named 23.0.0-AL2023. This is a Linux image that has OpenJDK23 pre-installed, which we need for our Java application. Then we have a run command instructing Docker to execute the following command, makedir/app, which creates a folder named app in the root directory. Now we have the copy command, copying from a target on the host system to a target within the Docker image. What we copy here is the catalog microservice we previously built. Next we have the workdir command, which sets the working directory for other commands, such as for instance the entry point command. This means that the subsequent commands will be executed relative to this directory. The last command we have is the entry point command, which bundles command parts and runs when the Docker container starts. Here we instruct Java to run the jar file of the catalog microservice we copied earlier. The Docker files for the other 3 Docker images are very similar in their structure. The Docker file for the front-end view looks a bit different to the others. Let's take a quick look. We start with the from command, pulling an image named node in a version named 22.9.0-bookworm, which has Node.js 22 pre-installed. We then make use of the run command to install the Nginx server to this image. Then we make use of the copy command to copy an Nginx configuration file into this image. We will take a look at this in a second. After that, we use the expose command to tell Docker to listen on a specified port. We need this, otherwise whatever is behind will not be accessible to us. Lastly, we use our entry point command to start Nginx. In our run script, we have a set of variables, and at the very end we execute the command docker compose upd, which looks for a file named docker-compose.yml. This is a configuration file to instruct Docker Compose to, well, compose all the containers. The file starts with a services section, which is used to define the individual services that make up this application. The next layer consists of 5 services we define, which are these here. Within each of these services, we provide the image name and version, a restart directive, and a name that the container shall have internally. Other than that, if we take a look at view, we also have a ports directive for a port mapping between the ports 8080 and 80. The Nginx server that we run within the Vue container needs a configuration as well. Let's take a look. What we will define here is that we listen for calls on port 80. If a call comes in, we differentiate between 5 locations that correspond to the 5 containers that we run. The first location is the root location that simply transmits what's located in the folder that is set in the root setting. We will later put our front-end web application in here. The other location definitions correspond to the microservices we have defined. The other location definitions correspond to the microservices that we have defined. Internally, we instructed Docker Compose to make the containers accessible over a virtual network. Every container has a name that he will be accessible over, meaning that we connect the local path to the internal remote path. This functionality is called proxy paths in the Nginx environment. Okay, we have the run scripts for creating this entire Docker environment. For the case that we want to remove all of them again, we need a remove script, one bash script for Mac and Linux, and a batch for Windows. We now have set up everything we need to run the Docker environment creation. Let's do that. Just like we defined before, this script will first copy the source code of all the projects into a temporary folder. Then it will compile every one of the projects. After that, it will instruct Docker to build one Docker image each. And after that, it will instruct Docker Compose to create a Docker container for every created image, having them work together as one. Now we have a single URL access for all containers, and we can test that quickly by making use of the postman. First, we make a GET request to localhost :8080/API/product/all. The result is the list in the body part below. Then we can use the same post requests that we have already created before by just hitting the send button again and then checking the result below in the body part of the response. Okay, we're almost done. Let's first move the Docker containers and Docker images we created before. Now let's create a new folder within the services folder named View. In here we will create a new React application that provides a view so that users can get something to click on and make use of the microservices located behind. To create a new React application fast without having to perform thousands of settings, we will make use of a framework called Vite. It requires the npm command to be present on our system, so make sure you have Node.js installed for this to work. Now, instead of remembering a long command, let's make our lives a tad easier and create a setup script. Again, a bash script for Mac and Linux, as well as a batch script for Windows. Let's run it. And within this quick instant, we already have a basic React project with TypeScript support. There are a couple of commands for building, running, and removing, but instead of remembering all of those, let's again create scripts for all of them. And now let's run the application using the run script. What this does is to run the application in a development mode, providing us with a view on localhost :5173. So let's open that in a browser. Whatever it is that we change in the code will automatically reflect itself here in the browser without the need to rerun the run script. As we deal with products in pretty much all cases, let's start by creating a product interface with the properties ID, product name, quantity, and price, just as we have already defined in the microservices. We will also be making get and post calls. To differentiate them programmatically, let's also create an enum HTTP method for that. Now let's master the app.tsx file, which has all the logic of our front-end application. As we get status messages as a response when sending requests to the microservices, we need a place to put them. For that, we make use of the useState hook that creates us a place to create greeting messages, products we ask in a catalog for, order status, payment status, shipping status, and every single action we perform, we define ourselves an action log. This may be a lot right now, but don't worry. In just a second we will see the end result, and it will all become clear by then. For every action we have, we define ourselves a function that is executed. Essentially, this means we will have a mask with 5 buttons. One for greeting all the microservices, and then one each for requesting products, ordering, paying, and shipping. Every function has about the same structure. First preparing the query, then executing the query, and then setting local variables so that we can see something within the mask. Okay, enough code talk. Let's see what this mask looks like. Looks neat, right? Now, we could fully test this mask here, sure, but we know it works, right? So let's put it there where it belongs, together with the other services within the same set of Docker containers. We need to adapt the run scripts. When having built all the Spring applications, they also need to build the React application. We also need to adapt the Docker file named dockerfile-view. Here we need to make use of the copy command, so that the ready-built React application is copied into the view container. That's it. Let's run the run script. What we see here is the final front-end mask. We can click on the greet button to get the greet message of every microservice currently running. The greet messages will be shown in the text field to the right of the button. Then, clicking on the product button will request the products from the catalog and will display their name and quantity in the text field on the right. The next step is the order button. This simulates the placing of an order of products that we send to the order microservice. The service then responds with a text of products that were ordered and their quantity, which is all displayed in the text field to the right of the button. After that, we click on the Pay button, simulating the payment process. The last button is for simulating the shipping process, also displaying its result in the text field to the right. The log at the bottom displays every click on any of the buttons. To sum up, we built an entire microservice environment using Spring Boot to build the microservices and using React for the front end. The best way for you to make sure you got all the details is to head over to GitHub and get a copy of the entire code discussed in this video. This way you can play around with the components at your own will. Also, I've set up a playlist for all the Spring topics, so make sure to check that out. If you found some value in the content of this video, hit the like button and subscribe to this channel. This is the best way to stay up to date with future videos just like this one on this channel. And also, it would mean the world to me to welcome you to the community. I would like to thank you very much for watching. See you in the next video.